In order to talk about fractions, we first need to tell what a fraction is. Fractions describe the smaller parts of a bigger unit. For example, think about a square divided into 4 equal parts with only one of these parts painted. So if we want to write the fraction of the painted parts of this square, we need to first count all the parts. So we have 1, we have 2, 3, and 4 equal parts. And then on the top of the fraction, so the bottom of the fraction is the total amount of parts. On the top of the fraction, we are going to put how many parts are there painted, or how many parts are we interested to. In this case, we're interested in the painted parts, so only one of them goes on the top. So if we want to write the fraction of the painted parts of this square, we have on the bottom 4, because we have 4 equal parts. On the top 1, because only one part is painted. And this is the fraction of the painted parts of a square, of this square. The top part of the fraction is called the numerator, and the bottom part of the fraction is called the denominator. Now, fractions not only represent these squares divided and painted parts, fractions in algebra, we use them as divisions because that is what a fraction is, a division. Every fraction can be written as a division. So if we have b divided by c, the first part of the division, the first number in the division, in this case b, goes on the numerator of the fraction. And the second part goes in the denominator of the fraction. So b divided by c can be written as b over c. Let's view some examples. We have 3 divided by 4. So the 4 is the second part, it goes on the bottom, on the denominator. The 3 is the first part, it goes on the top. So 3 divided by 4 is 3 over 4. 8 divided by 5, 5 on the bottom, on the denominator, 8 on the top, on the numerator. So 8 divided by 5 is 8 over 5. Let's see what happens if we have a negative. A minus 2 divided by 11 is still the same situation. 11 is the second number, so it goes on the bottom, on the denominator, and minus 2 goes in the numerator because it's the first number. And this is how can we rewrite divisions as fractions. But we do have to be careful because not all the fractions are allowed. When a fraction involves a zero, we must be very careful. There are only 2 scenarios when a fraction involves zero. The first scenario is when 0 is in the numerator of a fraction. Both 0 over 7 and 0 over 8, or 0 divided by 7 and 0 divided by 58, gives us 0. Because when a fraction has 0 in the denominator, the fraction is always equal to 0. If 0 is the only thing we have in the numerator, then the fraction is equal to 0. But the problem is when the 0 is in the denominator, like in these cases, 7 divided by 0, 58 divided by 0. When this happens, actually mathematicians still have not been able to determine if there is an actual answer for this. So we call it, for the moment, we say there is no solution, but what we actually say is this is an undefined solution. We don't know yet what is the solution of a fraction when the denominator is 0. So fractions with 0 in the denominator is undefined, no solution. Another important aspect of fractions is some fractions represent the same value, the same proportion, even if they have different numbers, different numerator and denominator. We call them equivalent fractions. But as usual with math, it's easier the explanation if we get it with graphical content. So let's see it. We have 1 over 2 and 2 over 4. These are 2 fractions, different numbers. The left one has 1 in the numerator and 2 in the denominator. The right one has 2 in the numerator and 4 in the denominator. Let's paint the left fraction first. That's 2 in the denominator, 1 in the numerator. So 2 equal parts, only 1 part painted. The right fraction, 4 equal parts, two of those parts painted. So those two squares represent our two fractions. Then what happens if we put them together? Let's see. As we can tell, when we put those two squares together, both fractions are painting exactly the same part of the square. This is that the right one is painting in two parts and the left one is painting in only one part. But they are both painting the same part, only one half of that square. So it means 2/4 and 1/2 are actually equivalent fractions because they represent the same value. We are going to learn how to get these equivalent fractions in a future lesson, but for the moment we know that two fractions, even if they have different numbers, they can represent the same thing. But let's view another example. We know math is easier with the more we practice. So we have 1/4 and 2/8. 1/4 has a 4 in the denominator, so let's represent that 4 with a circle with 4 equal parts. And it has 1 on the numerator, so we paint only one part of the circle. Then we have 2/8, so 8 is in the denominator. We need a circle with 8 equal parts. And then we have 2 on the numerator. So we need to paint two sections of this circle, 1 and 2. Now that we have represented the two fractions, let's put them together. And what we have that the fractions represent the same part of the circle. If they represent the same part of the circle, it means that these two fractions are equivalent fractions because they both represent 1/4 of the circle. So they are equal to each other. 1/4 and 2/8 are equivalent fractions. For more math lessons like this one, visit our website, mathusermanual.com, or follow us on Instagram at mathusermanual.